So let's take a look at lesson 1 on page 7. Again, why is it helpful to write numbers in different ways? If you would, scan the lesson, write the definitions for terminating decimal and repeating decimal. What are those two terms? And before we move on, if you go to page 10, so when we get to the end of this lesson, we're going to find that there is a building on the essential question. So this really focuses in on what we're going to be learning today, which is how can you determine if a number is a rational number. So scan through here. Here we go, repeating decimal and terminating decimal. So take a look at that, write it down, what those two terms mean for repeating and terminating. If at any time you need to, and I'm going too fast, you can pause the video. You don't have to just scramble to get everything done. Next, so we're looking at a rational number, which can be written as a comparison of two integers. Remember, an integer is a positive number, let's say like 2, and its opposite, which would be like -2. So these two numbers are integers. They're not decimals, they're not fractions, they're not irrational numbers like, let's say, pi, that goes on infinitely. They're going to be a whole number and its opposite and 0. So a rational number, define that in your own words, and then give me examples. So if I were to say a percentage, we could say like 23%. Now 23% can also be expressed in fraction form, like 23 over 100. And even at that, there are probably many that are able to reduce that fraction, simplify it. Another example is a fraction. So let's go ahead and choose a fraction like, let's go with 10/20. It's an easy one. So 10/20 is a fraction, which is a rational number. It has a positive integer on the numerator and the denominator, but we can also simplify that to 1/2 or 1/2. The next one we have is a decimal. So if we write a decimal, let's say 0.8, I don't know, 1, we can rewrite that decimal as a fraction. That's a ratio of 81/100ths, which is just simply 81 out of 100. And if you need a little refresher, we're going to be using decimals a lot. Remember, 10th, 100th. Beyond that would be 1,000th, 10,000th, and so on. Now, a mixed number looks similar to a fraction, but this is where we have a whole number that is attached to a fraction. Let's just say 3/4. So we have this mixed number 5 3/4. And we could rewrite this as an improper fraction, a different way to write this rational number. So a quick little way to change this from a mixed number to an improper fraction, we can take 4 times 5, which is 20, add the 3, and we get 23/4. So the root word of rational is ratio, and if you have highlighters, you're more than welcome to mark up your text to help you out so that you remember what these words mean. We have ratio in that word rational. So again, describe the relationship between rational numbers and ratios. Remember, we have here what a rational number is and that ratio. If you're not sure and you don't quite remember it, then come on down here to this real world link. So during a recent regular season, no, not so recent now, but a Texas Ranger baseball player had 126 hits and was at bat 399 times. Write a fraction in simplest form to represent the ratio of the number of hits to the number of at-bats. So we're looking at comparing these two numbers. So we're looking at hits over times at-bat. So it says that he hit 126 times and 399 at-bats. And then from there, you can simplify that. I don't remember it off the top of my head, but you can see here that 3 is going to go into 126, and 3 is going to go into 399. And so this actually simplifies to every 6 hits as a ratio, he would have been at bat 19 times. So again, I want to hear what you have here, the relationship between a rational number and a ratio. So what did you write? So we know that a rational number can be written as a ratio in the form of A over B. So A and B, just like our hits to bats, have to be integers. Now, the one thing here is B cannot be what number? So we know that A and B are integers, but B can't be what number? Did you say 0? So B cannot equal 0. All right, so at the top of page 8, we have rational numbers. This is a really nice diagram to represent the different types of numbers. So the first type of number that you learn when you're little are natural numbers. These are your counting numbers, starting at 1, 2, 3, going up. Then we have whole numbers, which include the number 0 and all of your natural numbers. The next set are going to be your integers. So they're these natural numbers, whole numbers, and their opposites, which we know that 0 doesn't have an opposite. And then we have our rational numbers. These are numbers that we can create that ratio with, where our denominator, B, is not going to be equal to 0. So when we're looking at these different types of decimals, we can take a look at repeating and terminating. Terminating is what you're used to looking at for the most part, because this is where they end. So the number that repeats here is actually a 0, but those zeros can be dropped. Whereas if you have a repeating decimal like this 0.833333, it's 5, 6 is going to go on infinitely. So we're going to look at how do we write this 0.83 that repeats. So what we're going to do is the terminating is easy enough to end because we can just drop the zeros. But if we have 0.83 and that 3 repeats, we're going to use this bar notation. And it tells you about the bar notation over here on the left-hand side. So for this, chapter, you can use your calculator. That is one of the nice things. There is one portion on the Florida FSA that you cannot use a calculator on. You do need to still know how to do long division. However, a lot of the questions will allow you a calculator. So if you want to use your phone, that's fine. If you have a calculator, go ahead and pull it out. All right, so to go through these examples quickly, you'll see the first one, 5/8. This is 5 divided by 8. Remember that fraction bar is a division sign. So if you take 5 divided by 8, make sure that as you're going through this, we know that 5/8 is less than 1. So 5 divided by 8 is 0.625, which is a terminating decimal. Now if you flip that around and you accidentally put in 8 divided by 5, you're going to get a whole number, 1.6. We know that this fraction here is less than 1. So go back and check yourself, make sure that number comes out to be less than 1. The next one is negative 1 2/3. Now when we're looking at negative 1 2/3, it tells you here in this example to convert it to an improper fraction, but you really don't need to do that. This integer that's attached to the fraction, we can just write that as negative 1 point something. And then on your calculator, if you take 2 divided by 3, you're going to get this 0.06 repeating, and then that's 7. That 7 doesn't really end there, it's just rounding it up so that it fits on the face of your calculator. So this is going to be 0.6 is the 2/3 portion. So we have negative 1.6, and that 6 repeats. So we're going to use the bar notation because 0.6 is not equal to 0.6 repeating. If we take this out another decimal place, we can say 0.60. We know that's not equal to 0.66 that's repeating. So just be careful where you're using that bar notation and what it really means. So taking a look at 3/4, hopefully you already know this. 3/4 out of 4/4, you should know that's 75 cents. So we have 3 divided by 4 is 0.75. Coming over here, negative 2/9. We don't need to worry about that negative, so we're just going to type in 2 divided by 9, check your answer, try it out, and then we get 0.2 repeating. Make sure that we add on that negative sign. We're not going to write out all those 2's, so we're just going to use that bar notation to show that it repeats. C. So we already have this whole number, 4. So just write out the 4, and then we're going to convert this 13/25. So you can either multiply the denominator and numerator by 4, because it's out of 100, or you're going to get the same result if you take 13 divided by 25, and you get 0.52. So that decimal portion of 52/100 gets tagged on. Try the next one. Again, you can pause the video, please try it yourself, and then come back and check your answer. So D is 3 1/11. So looking at 3 1/11, again, we have the whole number 3, and then 1/11. So we're going to take 1 divided by 11, try it out, and I want you to notice it repeats. Now that 1 again, don't be mistaken, it doesn't actually end there, it's just rounding. So we're going to put 0.09, and it's important you look at what number is actually repeating. On the calculator you can see the 0 and the 9 repeat. At the top of page 9, So looking at this real world example, in a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits and 530 at-bats. To the nearest thousandth, find his batting average. So we're going to find that just like we did on that previous real world example about the Rangers. We have his 175 hits over the 530 bats. So this is a ratio of 175 over 530. So we're going to do 175, divide by 530. It shows you here. And then it says to round it to the nearest thousandth. So remember, rounding to the nearest thousandth, tenths, hundredths, thousandths is 3 places out. So here, the batting average was .33. You can drop that 0. A good way to remember this: 4 or less, let it rest. So if we're rounding to here, we're going to take a look at the one just to the right of it to determine that. 5 or more, raise the score. So in a recent NASCAR season, Jimmy Johnson won 6 of the 36 races held. To the nearest thousandth, find the part of the race he won. So we need the wins, here we go with a ratio, over the total races. So we know that he won 6 races out of the 36 that he competed in. This will simplify. If you want to simplify, you can. 6 goes into 36 6 times and then convert it. It's going to come out the same either way. So if we take 1 divided by 6, what do you think is going to happen? We have another repeating decimal. So again, it tells us to the nearest thousandth. So we're going to put 0.16, and this repeats. So again, 4 or less, you let it rest. 5 or more, you raise that score. So just like it rounded it here, we're going to round this to a 7. All right, so for your first practice, I want you to work on page 10, 1 through 3. These are all converting your fractions and mixed numbers into a decimal. And then also on page 11, at the top, again, work out some more. You may use a calculator. And then also number 7, A through D. So this is your first practice on your own. Good luck.